Hello and greetings from Seattle. Today we are going to look at k-nearest neighbors, or the KNN machine learning algorithm. Why is it that the KNN algorithm is usually one of the very first supervised machine learning algorithms that many people learn when they are getting into data science? Well, to answer this question and also to talk about a bunch of other things surrounding KNN, we have put this short video, and this is how we are going to do this video. First, we are going to do a one-line overview of KNN, and then we will examine the advantages of learning KNN, and then we will look at the flip side of KNN, especially when it comes to putting KNN into production. And then we are going to take a 10-minute deep dive into k-nearest neighbors. And next week, you can expect Python code that implements KNN. It'll have all the essential components of a typical data science pipeline. So what is a good one-line description of k-nearest neighbors? The k-nearest neighbors, or KNN, can be split into two halves, right? There's the k and there's the NN. NN stands for nearest neighbors, which kind of intuitively tells you that we are going to look at the neighbors or the nearby points of something. And the K stands for a number. So we are either interested in 2 nearest neighbors or sometimes 10 nearest neighbors. But that kind of gives you a sense of where we are going. But please stay tuned to understand this algorithm much more deeply. What are the advantages of k-nearest neighbors? There are 3 advantages. And the advantage number 1 is that it's pretty simple to understand. And advantage number 2, KNN can be used to understand some of the core principles of good machine learning practice. This includes concepts like splitting the data into training, validation, and test sets, and learning about how to tune hyperparameters, and actually understanding what a hyperparameter is. And advantage number 3, KNN can be used for both classification and for regression. What are the disadvantages of KNN? Well, there seems to be at least one major disadvantage, especially when you are putting KNN into production. And this is that KNN happens to be a lazy learning algorithm. So what is a lazy learning algorithm? As the term suggests, if you are lazy right now, in order to get to where you actually want to go, you have to put in a lot of hard work at a later point in time. That is exactly the problem with KNN too. When KNN is trained and is put into production, at production time, whenever it sees a new example that it wants to either classify or regress, it has to go back to the training set and do more work. If you are really interested in learning more about this lazy learning algorithm problem, please go and check out this webpage. It also gives you some of the other disadvantages of k-nearest neighbors. It's not my webpage, it's a third-party website, but I thought it was a great resource. And before we decide to take a deep dive into KNN, if you really like this video, please consider subscribing to this channel. Thank you and enjoy the rest of this video.
KNN happens to be a very simple algorithm that you can easily understand. And we are going to use that as a foray into data science. So we are at the start line, as you can see from the slide. So what is the theoretical underpinning behind k-nearest neighbors, or KNN? It's based on the idea of similarity. Down here, you can actually see 3 pictures, right? So here is a bunch of really cute kittens, and here's a bunch of rather ferocious looking dogs, and here is another picture of cat, okay, most likely a cat. We call the dogs class 1 and the cats class 2. The dogs are also denoted by the plus sign, and the cats are denoted by the minus sign. So plus stands for class 1 and minus stands for class 2, which is cats. Now, where do we go from here? How can we do or put this in a machine learning context? Imagine this. There is an animal in front of you. You are not allowed to touch it directly. you are not allowed to see because your eyes are closed and maybe your ears are muffled too, so that you cannot hear whether the animal is meowing or is barking. But by asking questions to another person who is standing there, you have to predict or say whether the animal standing in front of you is a cat or a dog. How would you go about this? This is one way of doing it. So you'll say, okay, give me 5 cats and measure their heights. So 1, 2, 3, 4, 5, you measure their heights and also measure their weights. The heights can be recorded in inches or centimeters or whatever. Here we have done that in inches. And the weights are recorded in pounds. You might want to do that in kilograms or whatever. So we have the heights and weights of a few cats, and you plot them in this way. So wherever you see a minus, it's a cat. And then you say, okay, can you get a few dogs and make the same measurements? Measure their height and measure their weight, and then plot them on the same plot. This is what you can do, right? After your friend gives you these measurements, you can go to a place where you're allowed to see and you have access to a computer or a simple paper and pen, and you put plus signs for dogs. So this dog is here because its height is this much and its weight is this much. You're making a 2-dimensional plot. Why? Because there are just 2 features. The first feature is the height, which we plot on the x-axis. And the second feature is the weight, which we plot on the y-axis. So we have a 2-dimensional plot. If you get more features, like the color of the eyes, blah, 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 then you can add more features to your data. You make this plot, and then you go back to that person. Now you have to, your eyes are blinded again, you're blindfolded, and you can't hear anything. And you can just ask your friend that, okay, can you write down the height and the weight of this unknown animal whose identity you have to guess? This looks like a game, right? It's actually a game. So, and this is the unknown animal, okay? And your friend or the person who's standing right by the animal makes these measurements, the height and the weight. And you get to plot that, that, and you go back and you plot that. So this red spot corresponds to the unknown animal. You don't know if it's a cat or a dog because your friend hasn't told you that yet. In fact, you have to tell him or her. And you see that this is where that spot, the red dot, falls. If you are doing this by paper and pen, by doing this manually, you can take a ruler and measure the distance from this red dot to every other point. So for example, the distance from this red dot to this plus sign, the distance from this red dot to this minus sign, the distance from this red dot to this minus sign, to this plus sign, and to this one, this one, this one, this one. And you make a table out of them, right? So item number 1, most likely maybe this point, or the nearest one looks like the nearest one is a plus sign, right? So item number 3, that might be the item number 3, this plus sign, and the distance is, say, 1 centimeter. 1 centimeter to this plus sign. And what is the next nearest thing? So the nearest animal is a dog. Okay. So what is the next close one? You can sort this, right? You can arrange this in ascending or descending order. The next closest thing with the distance of 2 is a cat, most likely this one or this one. And then there is 2.5, which is also a cat. It should be either this or this. And then there are some things that are really far off. For example, the cat, which is 12 centimeters away, most likely is this point, this minus sign. So what you do with this table now, you can sort the rows by the distance from between the unknown and each and every point on the plot. Now, if you were to kind of, based on similarity, decide what is the animal closest in this plot to my red dot? You will say that it's a plus sign, right? Plus sign means a dog. What makes you think that? Maybe it just happened to be a small dog. So what happens if you look at two neighbors? Two closest neighbors, these two. One is a cat and one is a dog. So you cannot say anything, right? There is one vote that comes from the dog and one vote that comes from the cat. Two things that are really close to each other. You really cannot say anything. Oh no, I'm sorry, I cannot make a prediction. But what if you include 5 neighbors in the circle? 5 neighbors outcome is a minus, right? There are 3. How many minuses are there and how many pluses and minuses are there in the circle? There are 1, 2, 3 minus signs and 2 plus signs. And you say that because there are 3 minus signs, 3 neighbors that are cats, I think my animal is a cat and not a dog. Turns out you're right. But how do you choose between these 3? Should you say, look at just one neighbor? Or should you look at 2 neighbors? Or should you look at 3 neighbors? Or should you look at 4 neighbors or 5 neighbors or 10 neighbors? So in the k nearest neighbors algorithm, that is the value of k. If we are using the circle that encompasses or encloses 5 neighbors, the value of k is 5. And k is a hyperparameter. This is what you have to learn or pick using your validation set. How do you measure the distance between one point and the other? Say between the red dot and the plus sign? You can use a simple Euclidean distance. It's a very simple metric. Essentially, I mean, you take the straight line distance between them. But alternatively, you can use a bunch of other more complex measures, which we will get to in the next slide. There are many different ways to measure the distance. So these are a few other distance metrics that you can use to measure the distance between points. And this is how to calculate them. And if you want a PhD in machine learning, I have a problem for you. Come up with a new metric to measure the distance between any 2 points in a highly multi-dimensional space, not just in 2 dimensions.